In this video, we are going to learn how to graph quadratics in factored form. Factored form is sometimes also known as intercept form. It's called intercept form because it gives you the x-intercepts. It's called factored form because it is factored. So there are 3 steps for graphing in factored form. Step 1 is to find the zeros. So remember, zeros is just another word for x-intercepts. Now this is really easy to do because it's factored. So we can just let y equal 0. And so we'll have 0 equals 2x times x plus 4. Again, I'm just getting this from this equation right here. We just changed y to be 0. From here, you have 2 factors that are being multiplied together that give you 0. So either 2x equals 0 or x plus 4 equals 0. And we can solve each of these equations. To undo multiplication, I'm going to do division and get x equals 0. To undo addition, I'll do subtraction and get x equals negative 4. So we have 2 zeros. One at 0, so that would be the point 0, 0, and one at negative 4. So that would be the point negative 4, 0. X is 0 right here. X is negative 4 right here. So you'll notice that I left this part blank. This part right here in the middle is still for your vertex, and we're going to find that in a second. And then I just wrote 0 on the bottom because that's the greatest value, and I put negative 4 on the top because that's the least value. Typically, when we write our tables, we go from least to greatest. So these are our 2 x-intercepts. Parabolas are symmetrical, so we can count to get to the middle. So if I want to find the middle of 0 and negative 4, if I go 1, 2 this way, that gives me the point negative 2. And if I go 1, 2 this way, I get negative 2. So you just kind of count until you get to the middle. And so the middle of these 2 points would be my line of symmetry, which would be right here at x equals negative 2. So I know that that is the middle. Step 2 is to find the vertex. So it says find the middle value in between the zeros. So that's negative 2 right here. That's halfway between negative 4 and 0. And then substitute this into the equation and solve for y. So what we're saying is that x equals negative 2. So in this equation, we're going to let x be negative 2. So every time we see an x in this equation, we're going to replace it with negative 2. So 2 times negative 2 is negative 4. And negative 2 plus 4 is 2. Negative 2, or negative 4 times 2 is negative 8. So that's this point right here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. That would be this point right here. Once you have those 3 points, you can go ahead and graph your parabola. So this would look like this. Now, we have been using Desmos to graph lots of things, and so let me also show you how you can do this in Desmos. So remember, our original equation is right here, y equals 2x times x plus 4. So I'm going to go over to Desmos, and I'm going to type that in. Y equals 2x parentheses x plus 4. So I can see that I have a 0 at negative 4, 0, and I have a other 0 at 0, 0. And my vertex is at negative 2, negative 8. So you could also just type this into Desmos and copy down these 3 points and then graph it that way. Both ways are correct. So the last thing they want us to find on example 1 is a domain and range. Remember, your domain are your x values from left to right. Our graph is going to the left forever, so that's going to negative infinity. Our graph is going to the right forever, so that's going to positive infinity. Another way of saying negative infinity to positive infinity is all real numbers. Your range is your y values from the bottom of your graph to the top of your graph. The bottom of your graph is your vertex. Your vertex y value is -8. Our graph is going up forever, so that's going to infinity. So our range from the bottom of our graph to the top of our graph is from -8 to infinity. Let's go ahead and try example 2. On example 2, we have the equation y equals negative times x plus 5 times x plus 3. Let's go ahead and type this into Desmos. So I have y equals negative parentheses x plus 5 parentheses x plus 3 close parentheses. So I can see that my vertex is at -4, 1. So let me go ahead and write that down. And then one x-intercept is -5, 0, and the other x-intercept is -3, 0. Let me write those in a different color. Again, notice how my x values go from least to greatest. Now, it makes sense that our zeros are -5 and -3 because if we were to set these factors equal to 0, we would have x plus 5 equals 0 and x plus 3 equals 0. If I were to solve that first equation, I would get -5. And if I were to solve the second equation, I would get -3. So those are where that comes from. So -5, 0 is 1, 2, 3, 4, 5 right here. -3, 0 is right here. And then the point -4, 1 is right here. Again, you can find that all using Desmos. So then we can go ahead and graph our parabola. Your domain are your x values from least to greatest. Or sorry, from left to right, same thing. So I'm going to the left forever, so that's negative infinity. I'm going to the right forever, so that's positive infinity. So my domain from left to right is from negative infinity to positive infinity, which is the same thing as saying all real numbers. My range is my y values from the bottom of my graph to the top of the graph. My graph is pointing down forever, so it's going to negative infinity. The top of my graph is my vertex. My y coordinate here is 1.